My name is Sanket Bhattacharya. I am the Seismic Business Development Manager in Fugro. Me personally and Fugro as a company, we have made the transition from the seismic applications in the traditional oil and gas domain to the energy transition domain into the renewables domain today. And in my current role, I look into how to strategize the growth of seismic, the innovation in seismic, and its applications in the renewables industry. Achieving net zero ambitions in the energy sector involves several key challenges. First and foremost are the constraints related to resourcing in terms of skilled personnel, essential materials, and of course, requirement of assets. The availability of qualified professionals and the supply of critical components are vital for the expansion of renewable energy projects. Additionally, securing strong governmental and political support is crucial. Policy frameworks, incentives, consistent regulatory environments are needed to drive the transition from what we have seen in the past to clean energy. Another significant challenge is the harmonization of industry standards and practices across different regions. This will ensure that technologies and processes are not only compatible, but actually can be effectively scaled and integrated into existing systems. Finally, the adaptation of infrastructure to support renewable energy resources. This is crucial because it includes, amongst many others, the development of advanced storage technologies and the construction of new grids, which are actually capable of efficiently transporting energy from renewable sources to our consumers. Addressing all of these challenges requires coordinated efforts from governments, industry stakeholders, and us, private sectors, on a global scale. One of the biggest drivers of the energy transition is offshore wind. Since originating in Denmark in the early 1990s, offshore wind has actually established its strong presence in Europe with almost half of the world's 75 gigawatt installed capacity. And the offshore wind sector has global ambitions to reach over 260 gigawatt of capacity by 2030. So throughout the European Union, renewables represent the largest share of domestic energy production, with over 43% in 2023 compared to 6% for gas, 3% for oil, and maybe 19% for solid fuels. The milestone in Europe's transition to clean energy aligns with meeting many of the world's climate change targets. So as you can see, offshore wind energy is not only pivotal, but is actually one of the key critical pillars of this energy transition process. To support envisaged targets and accelerated growth in the global energy transition, an increased emphasis on cost and time saving, as well as supply capacity, will be needed. From a geoscience point of view, innovative solutions, workflows to optimize seabed and subseabed characterization is required to design, construct, and operate offshore wind farms. That applies to both foundation designs and cables. And we'll need them to address this growing demand at a global scale. In this context, the EAGE GET, which is, by the way, the flagship event, will provide the platform to delve into topics ranging from geophysical acquisition, including the role of autonomous and uncrewed vessels, seismic imaging techniques, to data interpretation and integration, including assessment of shallow subsurface geohazards. With focus on the recent advancements and innovations in both qualitative and quantitative geomodeling and characterization techniques, along with the use of the more of late AI and machine learning processes in addressing the challenges in offshore wind, EAGE GET will actually play an important role, a pivotal role, in bringing minds together for achieving a unified global success. In addition, it will also encourage multidisciplinary dialogues within the industry to support the understanding of regulatory frameworks and the role of geoscience, seismic, to support environmental and archaeological assessments in the offshore wind industry. Geophysicists, geologists, hydrographers, our engineers, environmental and numerical specialists from the offshore wind industry, which includes, again, regulators, developers, survey contractors like us, and consultants, along with academia, will come together to exchange insights on the latest developments across the broad scope of this offshore wind industry. We are keen to enable a multidisciplinary approach, a knowledge-sharing platform, by inviting both geoscientists and non-geoscientists to attend and contribute their insights into the various aspects of characterization in offshore wind. It will also include case studies of the geoscience value creation in offshore wind projects, as well as insights into the novel applications of existing techniques or new technologies for seabed and near-surface characterization. This key event is for all who are curious to learn more about the challenges and opportunities associated with the demand for efficient site characterization and risk mitigation strategies in the offshore wind sector.